Solid Edge delivers intuitive tools for complex shape construction, a must for designers of ergonomic and aesthetically pleasing consumer products. Here we have a kitchen appliance from one of our customers, Tefal. To demonstrate Solid Edge's capabilities, we'll redesign the rear panel of this domestic fryer to eliminate physical interference between its cooling fan and the rear casing. An industrial designer has modified the rear panel in conceptual sketches, so we'll display these in Solid Edge. This new design accommodates the repositioned fan while also providing a handhold to easily lift the fryer. We'll use this collection of sketches as a template to guide curve creation, ensuring we closely match the designer's vision for this part. Solid Edge allows us to generate a free-flowing yet customizable curve with a minimum of control points, yet drag any point and completely change the shape. In this case, we'll design one half of the new feature and then mirror to complete the design, so we'll connect the endpoint of the curve to the part's midline. Here we'll use two pre-existing sketches placed relative to the top and bottom in the industrial design sketch. Once again, we'll draw a curve to match the side profile of our template and connect the endpoints to these upper and lower sketches to define the exact start and end points for the final feature. We drag control points to replicate the conceptual shape. The cross and guide curves must be connected to create a successful surface feature, and Solid Edge Blue Dot does the job. We'll extrude this curve to create a construction surface for controlling tangency across the midline of a symmetric part. BlueSurf within Solid Edge enables us to loft a surface between the three curves while guiding its shape with the edge of the construction surface. Individual tangency controls ensure that the BlueSurf is tangent continuous with the construction surface and thus the mirrored face. Our next task is to trim away part of the surface we don't need. We'll project onto our surface an existing curve based on the conceptual sketch. Simple and fast. To complete this rear surface, we'll stitch together the two halves. The ruled surface command extends the edges through the existing casing part. Advanced rounding really aids aesthetics, so we'll place a constant width round along the edges. Next, we'll use surface body by boundary to cap off the inside of the surface body. Stitching these two faces will form a solid body that we can use to punch or emboss the original part. Simple and fast. We can finish the design by rounding the resulting edges. Since our design goal is to make space for an exhaust fan, we need to build in a vent. The vent tool constructs a customizable series of ribs and spars in an array using any basic sketch. Imagine creating this complicated feature with traditional cutouts and extrusions. Creating complex shapes in Solid Edge is easy, yet smoothness and flow of the final plastic is of utmost importance. In this part, we have 6 individual faces along the top. The Zebra Stripe visual inspection tool helps. Note that the zebra stripes reflect jagged transitions across the patches, so we'll use the Redefine tool to merge the 6 patches into one beautiful and continuous surface. Now that we've seen some powerful surfacing tools in Solid Edge, watch as we create complex geometry utilizing multiple solid bodies. This fryer uses a stirring paddle to ensure an even distribution of cooking oil throughout the food, so we need to design an arm coming off the paddle's mounting hub. To begin, we have a top view sketch of the arm's shape and a side profile sketch depicting how the top of the arm curves away from the center mount. We'll combine these sketches to generate a resulting cross curve of their virtual intersections. As we create a series of profiles through which we can create a lofted feature, we'll use the pre-existing curves to guide the feature's transition through the cross sections. At any point, we can make a change to the defining cross-section profiles. Watch how the complex lofted feature dynamically updates. In this case, we want to retain the original design. To finish this arm, we'll place a constant width rounds on the top edges. The end of the paddle is a proven design that we're simply going to integrate into our paddle arm. Watch as we use the Replace Face command to trim away the end of the arm body. Our final goal is to hollow out the paddle's face. A Replace Face option allows us to add a cross-section sketch which we can pull inward. That was easy. In this demonstration, we've proven that Solid Edge provides a broad collection of surface and solid modeling tools, perfect for creation of complex consumer products. Solid Edge. Design better.